Good morning to all. During the last class, we have already learned the different states of matter. That is solid, liquid, and gaseous state. These three states are visible to us. In addition to these three states, there are two more states. That is, the fourth state is plasma, and the fifth state is Bose-Einstein condensate. That was also noted in your textbook. In plasma state, the matters are the form of ions. The Bose-Einstein condensate was discovered by the Satyendranaths in 2001, and the actual nature is not founded by the science world. So you have to learn that visible states are solid, liquid, and gaseous state. Then the other fourth state is plasma, and the fifth state is Bose-Einstein condensate. It is commonly known as BEC. Today we are going to study about the change of state. Change of state. During last episode, you have seen an activity. In one beaker there is ice, the second beaker water, and the third steel vessel you have seen the vaporization of water. When you come into learn the states of water, the thing that came to your mind is this water. Water can exist in three forms: solid, liquid, and steam. The gaseous state of water is known as steam. In view of the ice, water, and steam, you can find out the reasons of almost all the properties of these three states. Today, basing in your mind, always there is solid. When the nature of state of solid is solid state, the thing came to your mind is ice. The liquid state, first of all, the idea came to your mind is the state of water. When the gaseous state, the idea came to your mind is the nature of steam, that is water under vaporization and go to form the gaseous state, namely steam. Now we are going to study change of state. In change of states, we are going to study what happens inside the matter. What happens inside the matter? The second thing is what happens to the particles in the matter? What happens to the particles? The third thing is how does the change occurs? How does the change occurs? In this episode, we are going to study these three things. What happens to the matter inside the water? When a solid state change into liquid state, or a liquid state change into a gaseous state. What happens inside the matter? The second is what happens to particles inside? When solid state change into water, what changes or what happens to particles? The third thing is how does the change occurs? How the solid change into liquid, or how the liquid change into a vapor. We can study these things in this class. In your textbook, there is an activity is given to you. That's a simple activity. You can do yourself. Take a beaker, put some ice in it, insert a thermometer, and heat. You know what happens? We all know that when ice is heated, it melts and turn into water. Ice is the solid state, and on heating, it changes solid state to liquid state, that is known as water. Here, we please note that the ice, it is the temperature is 0 degree Celsius. 0 degree Celsius or below. At 0 degree Celsius, we can't say it is the solid state. It may be either in solid or liquid state. Yet we heat it. On heating, the temperature rises and it changes into liquid. This may be, please noted that in a graph. Let the ice be taken is at minus 10 degrees centigrade. Let the ice may be taken, the temperature of the ice taken is minus. At first, the temperature noted in the thermometer is when we insert thermometer inside the ice, it may not minus 10 degrees centigrade. Then we go to heating slowly. What happens? The temperature rises, and each time we note the temperature. The temperature on y-axis and time on x-axis. At 1 minute, 2 minutes, 3 minutes, 4, 5 and 6 are onwards. Here temperature minus 10, 0, plus 10, then 20 and up to 100. Then we please note the ice now heating, the ice melts. And the ice melts and melts, and at 0 degrees centigrade it reaches a point. Then there is no change for a long time. Then it is raised to a very cheap. We please note the temperature of the ice taken inside the beaker is minus 10 degree Celsius. On heating, it reaches at 14 degrees Celsius and began to melt. When the ice began to melt, the ice began to melt at 0 degree Celsius. Then for some time there is no rise, shows the thermometer. For the means 1.5 to 3.5, there is no rise in temperature shown in thermometer. What happens to the heat given to the ice? We are continuously heating. Do you understand? We are continuously heating the ice, but when it began to melt, till the ice began to melt, there is a rise in temperature. Then when it has begun to melt, till it completes the melting, there is no rise in temperature. Now the question is this gap, we also gives heat. Where does the heat goes? Heat is a form of energy. We can remember that on heating the particles of ice. What are the particles of ice? The particles which are made of ice are the H2O itself. The H2O molecules absorb heat. The H2O molecules absorb heat and it melts. But no variation in temperature is shown in this part. What happens is, on melting, here the melting begins. Here the complete ice melting completed. On this portion melting begins and melting completed. On this part there is no rise in temperature shown. What happens is that the heat being given to the ice absorbs water molecules or the particles of ice particles and hidden in it. Then that is known as, that heat energy is known as latent heat. Here it melts, so it is known as the latent heat of fusion. That means what is latent heat of fusion? Latent means hidden. That means what we are heating from the beginning of at which the ice melts to till the melting completed. It takes here about 2 minutes. These 2 minutes there is no change in temperature shown in the thermometer. At that time we are already, the heating process is continuing, there is no stop. At that time the heat we given to the ice are stored in the water molecule or hidden in the water molecules. That is not heat, latent heat. Here, what is the definition of latent heat? Latent heat means the amount of heat required to change 1 kilogram of solid substance to liquid at atmospheric pressure. Here the pressure remains constant, no change in pressure. Pressure constant. Pressure constant. Then what is the other? For a uniformity, we consider 1 kilogram of ice. The quantity of ice here is taken is 1 kilogram of ice. Therefore, what is the definition? The heat required to convert or to change 1 kilogram of solid. Heat required to change or convert 1 kilogram of solid to liquid at atmospheric pressure. At atmospheric pressure is known as latent heat of fusion. Similarly, we can again find the latent heat of vaporization. Here, again we know that we have into our initial first we say that what changes occurs inside the particles. What changes occurs inside the ice particles? When we heating, the ice particles melts and changes into water. What changes occurs inside the ice particles? On heating. On heating, this is a big ice piece. On heating, what happened? This is an ice particle. On heating, what happened inside the matter? This is an ice. A big ice piece. What happens? The ice. We all already know that every matter, every substance is made up of tiny particles. On heating, what happens inside the particle? First is this. On heating, what happens inside the substance? What happens inside these particles? These tiny particles. On heating, the kinetic energy of the particles increases. On heating, the kinetic energy of the particles increases at first. We knew that there is no change from the beginning to the beginning to till the end of where the ice the melting is completed. At that time, we are given heat to the ice. Where does the heat go? That is the question. That first what happens on heating, the kinetic energy of the particles increases. Then what happens? Then we already know that in solid particles, in solid state, the particles are closely packed, tightly packed. There is the distance between the particles is very small. It can't be, the particles cannot be moved. Then what happens? Second, they began to vibrate each other on their position. The particles began to vibrate their own places. The solid state, the force of attraction is between the particles is very great. So they cannot move freely from it. But on receiving the kinetic energy or on receiving the heat energy from outside, the kinetic energy increases. The kinetic energy of the particles increases. The particles began to vibrate. Then continues the heating. We continue the heating. The next thing, if the kinetic energy increases to a limit, then what happens? It overcomes the force of attraction between the particles. It overcomes to a limit. When the kinetic energy of the particles increases and to a limit, it exceeds the limit, it exceeds the force of attraction, what will do? The particles move freely. They begin to move freely and it becomes to liquid or water. It becomes liquid or here the ice is taken, it changes to water. Then this is our first question. What happens inside the particles? What happens inside the matter and what happens to the particles? Do you understand? On heating a solid substance, what are it changes into liquid? How it changes into liquid? That is our question. How it changes into liquid? For example, here we taken ice piece. On heating, ice piece is made of H2O particles, tiny H2O particles. On heating, the H2O particles receives heat energy and its kinetic energy increases. What do you mean kinetic energy? Energy possessed by the movement of particles. The kinetic energy of the particles increases, but it is a solid, it cannot move freely. It can either increases and the particles began to vibrate their own positions. These particles began to vibrate their own positions. Then the heating is continued and there's what the particles do. The energy exceeds the limit of the attraction and each particles overcome the force of attraction each other and it thrown out and move freely into a liquid form, namely here it is the water. How these are the three important things you have to notice on heating. So this is happened. This process is happening here. Here we are heating, we can't see the naked eye, the kinetic energy of increasing or the vibration of the particles inside, or we can see what we can see. The slowly the ice melts to form a water. How does it happen? The particles increase, kinetic energy increases and vibrates and it overcome the force of attraction between the particles and begin to move freely. Then we can see ice slowly changes to liquid form. Then the heat given that process is known as latent heat of fusion. Latent heat of fusion. Then we calculate the mass of the ice is 1 kilogram. This is 1 kilogram ice. 1 kilogram ice. Then what is the heat required? The heat required to change or to convert 1 kilogram of a solid substance. Generally, we can't define ice. 1 kilogram of solid substance into liquid at the atmosphere pressure is known as latent heat of fusion. These are the changes occur while we are heating changing solid state to liquid state. The changes occurs are this latent heat of fusion. There is one more thing you must know is during this change, during this process, during the changing take place, there is no rise in temperature. During the change, either it is in solid form or in the liquid form. In between solid form and liquid form, solid state and liquid state, there is an intermediate state, that is the changes occurring. That change, there is no rise in temperature is shown. The temperature does not show, the thermometer does not show any rise in temperature. Why? the temperature given to the ice is used for the purpose of the particles inside. They absorb it. The particles absorb it. The water molecules absorb it, and it used to overcome the force of attraction. Hence, there is no rising shown in it, and that is taking place this part. Here it began to melt, and here it gains melt. After the melting is completed, here up to this point, it is ice. Up to this point, it is the process is taking place. Process is taking place. What is here? It is ice. Here it is melting. Here it is water. The temperature of the ice is minus 10 degrees Celsius. We are on heating. On heating, the temperature rises, and at 0 degrees centigrade, it began to melt. Up to negative 10 degrees centigrade to 0 degrees centigrade, the substance is absorbing heat. Here is the solid state. Here it is the process is taking place. Here it is the process taking place. It is beginning the melting complete. Here it is pure water. Then again the temperature rises. There is no, the melting is completed. The latent heat of fusion is absorbed by the particles. Then we can see the on heating water. Here there are the two things you have to name latent heat of fusion. Latent means hidden energy. The amount of ice taken generally is known as 1 kilogram ice. But the heat given this is known as latent heat of fusion. Latent heat of fusion. Then the other thing is latent heat of vaporization. You do the same experiment. 1 kilogram of water is taken here and insert a thermometer. It is also began to heat. It also began to heat. What happens? You can show it in a graph. Degree centigrade head time minutes 1, 2, 3, 4, 5. Here temperature 20, 40, 60, 80, 100, 120. We will have now the water is at a normal temperature 30 degrees centigrade. The 30 degrees centigrade water is, or the ice is heating. What happens? The temperature rises. How we can in each time we note the temperature. At first the initial 1 minute the temperature is here 30. Then it rises gradually. When it reaches the 100 degree, it began to boil. At 100 degree, then the thermometer shows 100 degree Celsius. It began to boil. Then what happens? At 100 degrees Celsius, the water began to boil. Then what happens? We see that the water molecules one by one goes upwards. The water molecules one by one goes upwards. At 100 degrees Celsius, the water molecules one by one goes upwards. That means what is change occurs here? Water is in the liquid state. It on heating and it becomes 100 degrees Celsius, it boils and it turns to water vapor. Commonly we say that this is commonly known as steam. Then in the graph we can see that at 100 degrees Celsius it is the temperature. Then there is no rise. At 100 degrees Celsius the temperature remains constant till all the water turn into vapor state. Then we can see there is a rise in temperature. Then what is the point here? In the case of latent heat of fusion, here also please note that the normal temperature of water is at room temperature. The 30 degrees is water form. The state is what? On heating, the temperature rises for 30 to 40, 60, 80 and 100. When it has become 100 degrees Celsius, it began to boil. Now the question is this: atmosphere. See here, what happens to the matter inside? What happens to the matter inside? What changes? Okay. Second question is, what happens to the particles? What happens? These are all H2O molecules, H2O particles, tiny water molecules. Third question is, how does it happen? What happens to the substance inside? What happens to the matter inside? On heating, the water molecules absorbs energy. It absorbs energy and its kinetic energy increases. What is the meaning of kinetic energy? The energy possessed by the movement of molecules. We already know that in the liquid state, the molecules are free to move. They slide one over the other. On heating, the kinetic energy of the molecule increases. When we continue heating, what happens? The liquid state also, the source of attraction between the molecules. When the kinetic energy increase, the kinetic energy of the particles increase the force of attraction between the molecules. It escapes from the surface. Each particle on the top of the particles it has only one side free. So at first the surface of the water molecules go to the atmosphere in the form of gaseous state. Here this stage, this point the water began to boil. Till the boiling completed for the liquid exists. In this point, there is no change in temperature. The temperature remains 100 degrees Celsius itself. At that time also, we are heating the liquid. Where does the heat be given goes there? When it is speed, we are also heating. At this time we are heating, but the thermometer shows no rise in temperature. Where does the heat go on? That is the point here. The heat given to the water molecules are stored in its molecules. That is known as latent heat of vaporization. Then can you define the latent heat of vaporization? This is water. What is the quantity of the water? 1 kilogram of liquid. Generally liquid, 1 kilogram of liquid. 1 kilogram liquid. The heat given to convert 1 kilogram of a liquid to the gaseous state is known as latent heat of vaporization. Do you know what is it? The amount of the weight of the mass of the water taken is, here water is taken, then we say water, or the mass of the liquid taken is 1 kilogram. The 1 kilogram of water is completely converted to gaseous state. For this, we must heat it for 5 minutes. Then the heat required to convert, to change 1 kilogram of a liquid to the gaseous state at atmospheric pressure is known as latent heat of vaporization. Latent heat of vaporization. Generally, the amount of heat can be measured by the unit, namely joules. This is not given in this book. Yet you have to remember it. We can get a clear definition to the latent heat of fusion and latent heat of vaporization. That means 1 kilogram of the heat energy required to convert 1 kilogram of solid to liquid is 334 joules per kilogram. That means we can again redefine the definition latent heat of fusion. The amount of heat required in joules to convert 1 kilogram of solid to liquid at atmospheric pressure. The amount of heat in joules, unit of heat is measured by the unit joules. Similarly, the energy required to convert 1 kilogram of liquid to the same condition of gaseous state is 2260 joules per kilogram. You can redefine the latent heat of vaporization. The amount of heat in joules, required to convert 1 kilogram of liquid to a gaseous state at the same at the atmospheric pressure. Then here is another term named sublimation. What is sublimation? On heating certain substance directly, some solid substance directly goes to the gaseous state. It does not undergo a liquid state. This process is known as sublimation. For example, some ammonium chloride is taken in a china dish. The substance taken is ammonium chloride. Ammonium chloride, NH4Cl, is taken in china. It is heating. A funnel is invert chloride. And to the tip there is a cotton is fixed there. What are the tips taken here? This is a china dish. What is taken inside the china dish? Ammonium chloride is taken inside it. It is covered with a funnel. Yeah, at the tip there is cotton is placed. What is also this cotton? Gases formed does not go out. Then on heating, what happens? Ammonium chloride on heating, it decomposes to give ammonia plus HCl. Here it is ammonium chloride, NH4Cl. NH4Cl is taken inside the generator. On heating, it decomposes to give NH3 plus HCl. NH3 plus HCl. Ammonium chloride is the solid state. ammonium chloride is the solid state. On heating, it decomposes to NH3 plus HCl. NH3 plus HCl goes upwards and it cannot go out through its way, it is closed. Here we can have something, we can say also white crystals of ammonium chloride. What happens here? Ammonium chloride decomposes to ammonia and hydrogen chloride gases. These hydrogen cannot escape from water, so at the tip they again combine to give NH4Cl. NH4Cl. Here what happens? Ammonium chloride on heating decomposes to give ammonia and hydrogen chloride. They are the gaseous state. Ammonium chloride in the solid state. Ammonia and hydrogen chloride are the gaseous state. It cannot escape, so it again combines to form ammonium chloride on the end part of this panel. Do you understand? Here what happens on heating, the solid substance ammonium chloride directly passes to gaseous state ammonia and HCl. It again combines to form what? Again also ammonium chloride. Similarly, naphthalene, iodine, and such substances are examples for sublimation. But what do you mean sublimation? Solid to gaseous state and reverse take place. No change between them. You can show it by and chart. Solid, liquid, gases. Solid on heating, it changes to liquid. That is called fusion. Liquid on heating changes to gas. That is called boiling or vaporization. On cooling, gaseous state to liquid, that is known as condensation. On cooling, liquid change to solid, that is known as solidification. Again on this solid substance, whenever you go through these states of matter, every time in your mind is solid, liquid and gases. In your mind comes first of solid, ice, water and steam. On heating solid, it changes state to form liquid. On heating ice, you always remember, on heating ice changes to liquid. That process is known as fusion, and the heat required is called the heat of fusion. And on heating liquid, again heating the liquid changes to gases. That process is known as, or the gases change to vapor. That process is known as vaporization. Vaporization. Water on heating, it changes to steam. That process is called vaporization. Then on cooling, what happens? The reverse thing happens. On gases, on cooling, it changes to liquid. That process is known as condensation. Gases on cooling, or the vapor state. On the vapor state, on cooling, it changes to liquid, is called condensation. Similarly, liquid on cooling, it changes to solid. That process is named as solidification. Here there is another solid to gas. On heating solid, it directly changes to gases. That is known as sublimation. On heating solid, but here we see that, for example, ammonium chloride, NH4Cl. On heating, what happens? NH3 and HCl are formed. Directly, it does not go to the liquid stage. On gases on cooling, what happens? It again changes to solid state. Here, Solid to gaseous state and gaseous to solid state are always called sublimation. Please note the changes, name the changes here. In the solid to liquid fusion, on the reverse side, liquid to solid is known as solidification. In the case of liquid to gases, vaporization, gases to liquid, condensation. But in the case of sublimation, solid directly to gas is called sublimation. Similarly, gases to solid is also known as sublimation. Solid to gas and gas to solid are already known as sublimation. Then, one more thing you have to know is effect of pressure. Effect of pressure. You see injection syringes in your home, you collect use the injection syringe and what is you check you can we already studied that solids are incompressible. Solids are incompressible. And likewise, liquids are also incompressible, slightly negligible. The liquids are also incompressible. The compressibility is negligible. Then the case of gases, it is compressible. For example, here we use inside it is air. We hold, we close the tip by the finger, then press it. Then press it. What you can see? We can't complete. You can press to a little. Then you can press to a little. Air inside is the pressure you can press to a the volume of the air inside is decreased. While we remove the finger, what please note the piston goes backwards. When we exert pressure, the volume of the gases decreases. On release pressure, the volume increases. You can do the experiment. On exerted pressure, the volume of the gas decreases. On release, it goes upwards. What does this activity shows? Air is the gaseous state. The volume can be compressed. It is easily compressible. Then what the changes taking place? On compressing, what the changes taking place? You can note that. These water molecules and the air molecules are free to move. They are moving freely in the piston. When we are pressing, what happens? They come closer. They come closer. The space, if we before escaping pressure, the space between the molecules are very large. We extend force. What happens? They come closer. The distance between the particles are very low. They come closer. Here we can see. You know what is dry ice? Dry ice means solid carbon dioxide. Solid carbon dioxide. Carbon dioxide gas can be. It is the carbon dioxide gas is the gaseous state. If we apply high pressure, what happens to it? The carbon dioxide gas on applying high pressure, it directly changes to solid state. Carbon dioxide gas on applying high pressure, it changes to, and temperature also decreases, changes to solid carbon dioxide. So the industrial name of carbon dioxide is, solid carbon dioxide is means dry ice. Dry ice What is chemical name? Industrial name of salt carbon dioxide? Salt carbon dioxide is commonly known as dry ice. Then there is a question: why it is called dry ice? Whether it is not called wet ice? It is called dry ice because it does not go through the liquid state. It does not go through the liquid state. Gaseous to solid. Only release pressure, what happens? The solid carbon dioxide directly goes to gaseous carbon dioxide. It also does not go through the liquid state. So it is called a dry ice because it does not form the bound in the liquid state. Solid carbon dioxide means carbon dioxide either in the solid state. In the solid state it is called dry ice. The gaseous state it is commonly carbon dioxide. It does not form the liquid state. On applying pressure, the gaseous state directly pass through and change into gaseous carbon dioxide directly change into solid carbon dioxide. So it is called a dry ice. You have take the name dry ice. Then one more thing is evaporation. Evaporation. It is a common name. The common name given with familiar dress. When we wash our dress and hang in sunlight, it will be dry within a few hours. How we can dry the clothes very easily or quickly in rainy season? You go to you return the home after school at 6 o'clock or 7 o'clock. Uniform, and there are only single, consider you have only one uniform. The next morning you have to wear it. How we can wash and dry the uniform very quickly? What do you do? After washing your uniform, what do you do? There are two things. You spread it. You spread it in sunlight. Then there is the water molecules present, it evaporates into the atmosphere. So the second thing what you can do for quickly drying your dress, you put it in a room and you switch on the fan. If it is the wind or the fan is on, we already know that the dresses dry up quickly. So what is evaporation? Evaporation is the change of a liquid state to the gaseous state at below the boiling temperature. We already know that water boils at 100 degrees centigrade. At 100 degrees centigrade, the water boils and changes from the liquids to gaseous state. If the boiling takes place at a fixed temperature, at 99 degrees centigrade, the water does not boil. But at the same time, in 20 degrees centigrade also, the evaporation takes place. That is the difference. We have between evaporation and boiling. Evaporation means what? The change of a substance from liquid state to gaseous state below the boiling point. Then what are the factors depends upon the evaporation. One, surface area. So we spread the dresses, spread it in sunlight, it evaporates quickly and dry up. If we wrinkled the shirt or dress, it does not dry up quickly. Then wind, if wind is blowing, the dresses dry up quickly. If there is no wind, it takes time for drying up. Surface area, drying, wind, then if you take some water and place in a sunlight, you take some water in a test tube and some other water or another place in a vast opening. If here the water evaporates slowly, it depends on the surface area speed. At the same time, this rate the water evaporates quickly. The surface area and wind are the two. But then the third fact is humidity. What is the humidity? The amount of water vapor present in the atmosphere is known as humidity. If the humidity is high, the tendency to evaporation is very low. Similarly, temperature. For the four factors affecting evaporation are mainly surface area, one surface area, second wind, third humidity, and the other thing. So you have to also temperature. If the temperature increases, you are in a hot season, the dresses are always drier quickly. Then we have to learn one more thing. Distinguish between what are the difference between evaporation and boiling. Evaporation takes place on the surface only. You may please note the difference between evaporation and boiling. Evaporation takes place on the surface only. At the same time, boiling, we see that on boiling the water, the entire liquid boils. It's a bulk phenomenon. The second thing is, evaporation takes place at any temperature, but boiling takes place only at a fixed temperature. Evaporation is a slow process, and at the same time, boiling is a fast process. During evaporation, we feel a cooling effect, and at the same time, boiling no cooling effect. We already know that after doing an exercise, we can take rest, we sense a cooling effect. How it cooling effect happens? The water molecules in our body, on the skin of our body, evaporates, and the water molecules, the amount of energy required for the evaporation is taken from our skin and from our body. So we feel a cooling effect. So, likewise in summer season, which shirt is commonly we use cotton or polyester, which has a cooling effect. We use in summer season, we use cotton shirts, small holes in it. So we already know that during summer season we sweat. The particles of sweat are vaporized. If you wear cotton shirt, the particles of sweat are undergo vaporization through these small holes of the cotton shells, and we feel a cooling effect. So similarly, in summer season, we kept water for drinking in earthen vessels. Why in earthen vessels there are small holes, and through these small holes there is vaporization takes place, and the amount of heat required for the vaporization takes place inside the water molecules. Therefore, the water inside the earthen vessels are more cool than at the same time the water kept in aluminum or other metallic vessels. So in your offices and school in the institutions, you already see that the water for drinking purpose is kept in earthen vessels. Why? It has a cooling effect. It was more cooled than the other water kept in metal vessels. Similarly, generally what is the state of the water at 25 degrees centigrade, 0 degrees centigrade, and 100 degrees centigrade? Can you guess? My question is this: what is the state at 25 degrees centigrade, 0 degrees centigrade, and 100 degrees centigrade? We can make only sure at 25 degrees centigrade it is the liquid state, water. At 0 degrees centigrade, we cannot confirmably say that it is the solid state. We cannot say it confirmably. That is why we have seen that at 0 degree centigrade, it began to melt. So there is a mix of solid and liquid. We can't say that it is liquid itself or solid itself. At 0 degree centigrade, we have seen that it began to melt till before below 0 degree centigrade, we can confirm that there is the solid state. Above 0 degree centigrade, we can say confirm that it is the liquid state. At 0 degree centigrade, it may be either in the liquid or in the solid form or the mixed form. Similarly, at 100 degree centigrade, we can't compare to say that it is the gaseous state. What the reason? At 100 degree centigrade, it began to boil. Therefore, there may be a mixture of the liquid state and the gaseous state. At the both. So, above 101 degree centigrade, we can confirmly say that in the gaseous state. At 99 degree centigrade, what is the liquid state? At 100 degree centigrade, there is either the liquid or a gaseous form. Similarly, heat can be measured by joule. Similarly, another scale. Commonly we use to measuring temperature, we use degree Celsius. Degree Celsius. The boiling point of water is 100 degree Celsius. In your textbook, there is another term, namely Kelvin scale. Kelvin scale. You have to study about this. For measuring temperature in laboratories and scientific labs, they use Kelvin scale. What is the difference between Kelvin scale and degree Celsius? Degree Celsius. There is no difference. In the degree Celsius is commonly used and it depends upon the melting and boiling point of water. 0 degree centigrade is the melting point and 100 degree centigrade is the boiling point. But in Kelvin scale, it is the boiling melting point of ice is Celsius scale 0 degree centigrade, Kelvin scale 273 Kelvin. Boiling point in liquid water is 100 degrees Celsius. In Kelvin scale, it is 373. What is the reason? These two scales also all used in our textbook. The reason is that you have to convert degrees Celsius to Kelvin scale. That is 0 degree Celsius is equal to 273 K. The normal room temperature is 30 degrees centigrade. Normal room temperature is 30 degrees. In Kelvin scale, it is plus 30 is 303 degree Kelvin. The boiling point of water is 100 degrees Celsius. In Kelvin scale, it is plus 100, 373 Kelvin. Then to convert any temperature degree Celsius to Kelvin scale, you are 273. The temperature of an ice is minus 20 degrees Celsius. In Kelvin scale, it is minus 20 is 253 Kelvin. Do you know how to find out the reason? You must please be aware that in Celsius scales, the scientists discovered that the minus degree, from 0 degree, the temperature can be degrees from 0 to up to infinity. negative 100, negative 200, negative 300 to infinity in Celsius scale. But in Kelvin scale, the Kelvin found that the lowest temperature attained a substance is minus 273. The Kelvin denoted this temperature at 0 K. Then when he comes, the temperature increases, it becomes 0, it becomes 273 K. Do you understand what I say? You need not understand. You must please remember that the Kelvin scale, the Kelvin scientist Kelvin found that the least temperature a substance can be attained is minus negative 273 degrees centigrade. He declared that the 2 minus negative 274 that a body cannot get. So that negative 273 degree he noted at the 0 Kelvin. Then he increases when 1 degree Celsius is equal to 1 K. Then negative 272 means 1 K. Negative 100 means 173. 0 means 200. There is no need to please remember it. You are required to convert degree Celsius to Kelvin scale. Convert 25 degrees Celsius to Kelvin scale. 25 degrees Celsius to Kelvin scale. 273 plus 25 is equal to 298. You must study this only. This come to this that Kelvin think that there is the lowest temperature that a body can attain is negative 273. And negative 273 is Kelvin considered as the 0 K. Then he increase temperature. The difference is in Kelvin scale there is no negative temperature. That is the difference. But in the case of Celsius scales there is negative temperature. Today this chapter is over. You are prepared for the coming examination and well written and well done in the coming examination and acquire 100% marks. Wish you all success. We can see again. Thank you.